I'm Steve Smith. I am one of the co-founders of the Architects Forum, so I get tapped to present on occasion. I'm a CLA, have been for quite a long time. I'm a consulting software architect. I've been writing LabVIEW code for longer than I should probably admit in public. It's quite a while. I am old. I am old. I'll be 49 on Friday. I'll go ahead and share that with the room. Yeah. All right. So you can find me on LinkedIn. That's where I am. You can find me at a personal website. You can find me there. Go check me out. I do cool stuff. Really, I promise. A lot of you know that as one aspect of my rather lengthy career is I did spend 6 years in building B across the way in systems engineering. It was a good 6 years. Got to know some really cool people. But that time has ended, and I'm back out on my own offering my services to the public at large. When I was in systems engineering, I was NIACS on the forums. Now that that time has passed, I'm just ACS. That is my actual forum handle. Yeah, I thought it was cool, so I went with it. What am I going to talk to you about today? Well, I'm going to talk to you about one of my favorite topics. Someday people are going to tell me they're sick of me hearing me talk about this, and I'll find something else to do. But in the meantime, I love talking about Actor Framework. I was on the feature team. I think I still am technically on the feature team, since Actor Framework is kind of a community thing. I have been and continue to be a big evangelist for the framework, as at least 2 people in this room can attest. And now I'm going to talk to you about communicating between targets running Actor Framework systems. And you have options. You have a couple of them. We'll talk to you a little bit about where this is coming from and what problem we're trying to solve, or class of problems we're trying to solve. And then I'm going to talk to you about 3 different solutions to that particular problem, one of which is fairly well known at this point. The other 2 are a little more obscure. And I'm actually hoping to turn you guys on to the possibility of using the other 2 options. They apply to a slightly different use case that I think is underexplored. I think we can do some cool work there. All right. Background. What am I talking about? Who here has not heard of the Actor Framework, or is not comfortable with it? Okay. I don't know what's going on out in our home audience. So the studio audience, everybody here has heard of it, which I guess is why they're here. I will blaze through the obligatory background slide. The framework for building high concurrency systems. Lots of parallel processes that need to talk to each other. Actors are parallel threads with data and function, and they send and respond to messages, and that's how they live in the world. If that sounds an awful lot like queued message handlers, you're right, because at its heart, an actor is just a queued message handler. But it is an object-oriented queued message handler design. The whole framework is object-oriented, which lets us leverage all the cool stuff we get with OO, mostly about extensibility and reuse, build complex actors to inheritance, build systems from sets of actors. One of the things that we hope to achieve with Actor Framework is to have a common framework that lots of us are using in different places, because that encourages reuse and that encourages collaboration. I have written actors that are available for you to download, to use in your project. And I hope that more and more people will start to do this, especially for that class of problem of the kinds of glue code, the kinds of pieces we need to build that are horizontal across a whole bunch of different kinds of systems. Most people think of reuse. I'm going to solve this particular problem. But they're the only ones that care about that, so nobody else is interested in reuse. But the whole category of reuse things, like how to talk between targets, that is common to lots and lots and lots of applications. That's where our reuse is. So, multi-target system. This is a typical one. This is not the only kind, but it is the one that shows up in a lot of anti-marketing literature. It is kind of the canonical. I've got a PC, and it's running a front-end application, and then I've got a compact Rio or SB Rio or PXI or something else that's running a headless application that I want to have sitting there doing its thing. Lots of permutations on this. The exact hardware mix can be a lot more involved. You get a lot more connections than just the one-to-one connection that I'm showing you here. But everything we want to talk about today, everything I'm going to talk about in the next 45 minutes, can be covered by looking at this basic use case, so we'll go with this. Now, Actor Framework was originally envisioned with a single target in mind. And this is what it looks like on a single target. You'll have a process, you'll launch top-level application, you'll launch your first actor. Actors can launch other actors, and they will do so. And you'll build up, as you launch processes and sub-processes and UIs and data acquisition units and so on and so forth, you'll build this tree of actors that talk up and down the tree to each other. That's your typical single platform application, kind of the canonical model for AF. Well, let's go and try to map that onto what I showed you on the previous slide. And we find that, okay, we've got a problem. Because we've got two targets, there's a tendency to have two applications, right? We have the headless one running on the Rio, and we have, say, a UI that we want to connect to for monitoring purposes. Well, that's no longer a single tree. That's two trees. We have to do a sibling connection between two of the actors. That's okay. Not the default model for AF, but sibling communication is allowed. I can connect two actors together that don't have a, other than through their parent. That's perfectly all right. But what do we do here? We can't. Queues don't go across target. I can't run a queue from my desktop down to my Rio. I know there's folks that are working on that, but I can't do that right now. Got to do something else. So what do we do? How many of you have written multi-target applications? A good chunk of the room. I just got tested on one such. Plaid actually involves something like this. So what do we do? Very common solution is to go, all right, fine. I have to have something broker that communication. So what I'm going to do is I'm going to have my processes, and they're going to have this sort of dependent nested process, a nested actor, if you will, whose job it is to broker that communication. So each of my processes launches an actor whose job is to reach out through some protocol to a counterpart across that application boundary and connect, and now I can trade traffic back and forth. We shipped AF in 2012. I was here at the time. And I think within, concurrent to shipping it, I wrote my first, broadly distributed reuse actor. It was called a linked network actor, and it addressed this problem because I knew it was going to come up. Linked network actor was pretty cool. Did exactly what I just described. Your actor would launch a linked network actor, and it would go find somebody to talk to, and then you could trade messages. It was bidirectional, because boy, I hate having to do twice the work to get connections up. I want to have one connection and be done, right? It uses network streams, which are pretty exciting. I wanted to play with those, so I did. And it's persistent. You had this linked network actor sitting there all the time, and you would tell it to connect or disconnect, and that was a really useful thing. However, and this I don't know how many downloads it's had, but just based on the number of random people I've never met in my life who reached out to me directly, hey, I'm using your linked network actor, and I'm having this challenge or have this question. I know this reached a lot of people. Solved this problem for a lot of people, and that was great. However, within a year, I knew I was limited on this. And the challenges that I had, the big one was no TCP/IP. Network streams are platform specific. Have them on Macs, have them on Linux. Kind of a bummer. Also, there's some challenges with network streams and firewalls and stuff. Being able to use straight up TCP/IP was important, and I was getting requests for that. Because of the way it went and got put together, it was kind of not actor-like in that if I wanted my linked network actor to send a message, what I had to do was I had to say, hey, linked network actor, I'm going to send you a message that another message is a payload. Transmit this message across the network. Which means you had to you had to bundle that message up with all of its data, you had to package it into other actions. It was cumbersome. It didn't feel like Actor Framework to me. That aspect of it, and then some issues with persistence, and trying to keep this actor persistent all the time, made it very cumbersome. It didn't flow as naturally as I would like. It worked, it solved the problem. Thought I was getting the sense that it could be better. And I did make something better. And for that reason, linked network actor is deprecated. If you're using it, you can still get it. It's still available for download. Nobody's working on it. Nobody at NI, because I was the guy that was working on it, and I'm not here anymore. And I'm not working on this in my spare time. It is available. I don't think you even made it to the tools network, so you just have to get it as a forum download. You can find it. If you still want to use it, feel free. But you're pretty much on your own for support. LNA? Not anymore. Not anymore. I took it out of the course in favor of what I'm going to show you next. As my effort to kill off my own child. I'm such a horrible person. I learned a lot from doing this, but I've got better ways to do this. And what is that better way? That better way is nested endpoint actors. I'm going to hydrate the presenter. Okay. Still solving this problem. Doing exactly the same, filling the exact same role as the link network actor. So if you want that client-server connection, I've got a thing running headless that I want to reach out and talk to it. This is the component for you. The great thing about nested endpoints. Well, they support TCP/IP and network streams, and whatever other protocol you can shoehorn into the API. It is extensible. If you want to try to, I don't know how it would work with UDP, but you could try it, probably make it work. If you wanted to play with a CAN bus or something like that, you can do that. You should be able to. If not, I may have some work to do. I was able to get rid of the transmit message. That was a really exciting thing. Along the time I was working on this, we made a change to actor framework, and we introduced another override called receive message. Receive message changes how actors handle a message that they receive. They don't just do you can change how they process it. Most users, most of the time, never going to touch that override. It's the least used one in the framework. But it was intended for exactly this sort of thing, and so I took advantage of it. There's no transmit message. If I send a nested endpoint a message, it will simply forward that message across the network. So it's completely transparent, very actor-like response. The other thing that I did that really cleaned up how it worked and how it operated is it's not persistent. I think for the longest time I was laboring, and I think other people were too, with the notion that if I launch an actor, it has to be there the whole time the system's running. It's simply not true. You can have an ephemeral actor like this. I launch my nested endpoint, and it's going to go and find its connection right away. When that connection breaks for whatever reason, my nested endpoint's going to go away. It doesn't have to stick around. If you need persistence, I can get it for you, and I'll show you how in a minute. But the actor itself doesn't need it. Much cleaner, much more actor-like, much more intuitive to use. Under the hood, it looks like this. This is the design. Message streams are just an API for handling message traffic. They're simple, straight-up LabVIEW classes, simple railroad track VIs, no actors involved there. API is really simple. That's the thing that you override to make your own protocol. The network endpoint's job is to manage the connection and disconnection and to move messages between network space and actor space. And then the nested endpoint is a very specific flavor of network endpoint that solves this class of problems. Yes, there is another child of network endpoint, which I will discuss shortly, which answers a different set of challenges. But we'll talk just about the nested endpoint for now. Using them, very simple. You nested endpoint, you do have to tell if it's TCP/IP or network streams, and you do that through a simple, giving it this object that it's going to use for communication, strategy pattern for those of you who geek about that sort of thing. And then you launch the actor. And that's all you have to do. It will go out and try to connect. You'll notice that this is create TCP stream listener. Due to the way TCP and network streams work, it's useful to have one side as dedicated listener for a connection and another side that's dedicated initiator. The listener, you launch it, just sits there and waits for connect. Okay, if it's TCP, it's that wait for connection VI. The initiator, you have to use that one. You just give it its remote address, and it will go out and it will make the connection for you. So you're specifying, you're identifying roles based on which exactly it's going to launch. Once they're up and running, there's the message handler that all actors have. There's an additional receive loop whose job it is to receive traffic from across the network. When you launch a nested endpoint, we create a connection in both directions, so we reach out across the network and connect, and then we get a connection back, and now we have bidirectional communication. At that point, a process can send a message down to nested endpoint. Message handler will forward it to its counterpart, and of course it works same in reverse. Okay. We do not forward every message. There are 3 that we chose not to forward. Stop is kind of obvious. I want if I'm relying on stopping my nested endpoint as the way to break connection, I need my nested endpoint to respond to a stop command. Otherwise, I'd establish a connection and I would send a stop, and the stop would go across the network and get passed up to the remote connections caller, who would then stop, and then I would have my nested endpoint sitting there floating in space, and this is not the desired behavior. So I do handle the stop message locally. Stop kills your connection. It kills the local actor. I need to report error internally to track, errors in communication, so that does not get passed along. And then last act gets handled locally as well. Again, these are down at the bottom of the hierarchy, so they shouldn't see a last act, but the other flavor of network endpoint does. And so I preserve the ability to handle last act locally. Now, some of you are asking, probably, about persistence. Well, okay, I've got my headless system, and I want it to always be available to connect. And so when a connection breaks and my connection actor dies, I need to be able to restart it. That's easy. Who here has played with last act in Actor Framework? A much smaller set of hands. Last act is your friend. Last act is the unsung hero of Actor Framework. It is worth a lot of time staring at the ceiling, thinking about how it works, because it is awesome in terms of what you can do. When an actor stops running, it sends a last act to its caller. That is a guaranteed operation if the actor actually launches. The last act contains several pieces of information. The last act is handled by the caller in a VI called handle last act, in the last act core, actually. And you can override it, you can change that behavior. One of the pieces of information you get back is the actor in its non-running form, just as a LabVIEW class. Okay? And it contains the complete, because it's the object, it's the complete final state of the actor when it's shut down. Well, okay, we don't need to change, if you've got a TCP listener sitting there on a local port, you're not changing your port number, you're not changing any of the settings of that nested endpoint. So we can just restart it, and we can do it right there and handle last act. So as soon as the connection dies and shuts down, we turn around and we can start waiting for the next connection. It's really slick. These are the kinds of tricks you can do with last act, and they really reduce the body of code that you have to write if you're comfortable with using it. All right, so this is awesome. But of course, nothing is free. There's always some pain, because life is pain. But he tells you differently. He's trying to sell you something. And there's a little bit of work that you have to do. Now, if I want actor A, my host actor, to send data to the target actor, what does it have to do? It has to send it a message specifically. Okay? So that message is over here. And it's in this library with the target. Okay, it's a part of this guy's API. And so if I go, I'm going to grab the send VI from a message out here, and I'm going to pull it over here. Well, what happens? Now I've pulled code from this other project into my local project. So I've got 2 projects showing up here, right? I pulled code from this project into this project by virtue of dropping this guy down here. And that locks the LabVIEW class, the message class, which of course is in a library with the target class, so it gets locked. Then if this target class is statically connected to any other LabVIEW classes, like the actor that launches, it's going to pull it into them as well. It's going to be locked as well. Now I've got all this code locked. It could be my whole project if I haven't done a really good job of partitioning my code. And properly partitioning your code can be a lot of work, so you don't do it unless you have to. Now, if I go the other way, right, I want target to send a message to host, I got to do the same thing, and I'll pull a host VI in, and I'll get the exact same result. I'll have my whole project locked up. And it gets worse. Because if this is a Windows target, and this is an RT target, SB-RIO target, I guarantee you there's some SB-RIO code in my actors over here. And there's some Windows-specific code in the actors over here. And they can't run or load cross-platform. And so not only is this code all locked, it's all broken. Yeah. Yeah. Gotta like that. This is intolerable. Fab thinks that intolerable is not a strong enough word for this situation. I'm going with, I've been hanging out with too many Brits, so I'm going with classic British understatement here, and I'm just going to go with intolerable. Let's not do this. Let's do something else, shall we? Well, what is that something else? That something else is to actually, apply all that computer science knowledge that we've been soaking up just by virtue of hanging around computer guys. We're going to introduce an interface class. This guy right here, okay? The drawing's a little not quite right. This is actually the same actor. It's an interface class. It's abstract. Doesn't do any work. Defines an API. And then I'm going to make children of my interface class that do the real work, and they do the real work on my specific platform. Okay, now let's dive into this in a little more detail and see how this actually works. As I said, the interface actor defines an API. If you've taken the AF class, we call this low coupling, but it's just an interface. It defines every message that's going to cross that application boundary. You might have more than one of these actors, by the way, but at least for the body of information it's passing, it handles all the traffic going in both directions. I'll show you why that's okay in a minute. But the methods that those messages call are dynamic dispatch and empty. They're virtual. They do no work. They're intended to be overridden. Okay? Now, the receives every message that crosses the application boundary. The first time I thought about it, I'm like, wait a second. I'm going to have something that can receive messages for the target. I'm going to have a different interface that receives messages for the host. That's not actually true, because the children of these things that I make have to be able to handle any message. If you're sitting there, right, and you're the interface, and you get a message from your caller, you need to know how to process it and forward it. So that's going out to your remote. You get a message but you can also get all the messages from the remote, and you have to process them and send them to your caller to work with them. So really, every message goes through the interface. Our remote proxy actors are children of this. They override parent methods to do two things, as I said. They're either going to act locally on remote messages. Okay, I got a thing from my target telling me to update my UI, so I'm going to do that. Or the user pushed a button and I need to tell the target to do something, so I'm going to forward that across the network. This is why the interface can handle messages bidirectionally. In fact, it will. The remote proxy actors themselves, they're children of the interface, and it can be the final recipient. We can use it in a couple of different ways. So it can be the UI, for example, the ultimate end consumer of that data coming across the network, or it can be an agent that forwards data on to a caller. Either are okay. This does not completely eliminate, but dramatically reduces, to a manageable level, the amount of coupling we have between our LabVIEW projects. In this case, the cooler interface class, one of my interface classes, it's locked. Nothing else is. Well, nested endpoints are, but that's reuse code. You shouldn't be touching that. The only thing you're worried about is the cooler interface in this case. And it would be nice if we could just work on it, but I don't think it's terribly unreasonable to say no. You gotta modify your interface, close one of your projects down, mod your interface class, open your project back up. That's manageable. Questions on coupling? All right, cool. Moving on. A little bit more housework that you have to do once you've done this coupling. This becomes really important when you're doing rules. You have to make sure that the message classes that you're receiving are actually. If I send a message class, I flatten it to string and send it across the network, which is how all this stuff works. Recipient gets that. I'm going to unpack that as a base message class. It does actually have to become whatever the final message class is. But unless that's loaded into memory, LabVIEW doesn't know how to do that. And so what you'll get is a base message class instead of specific message class that you care about. So any message class you're receiving from a remote location, you have to guarantee loads. The only way to do that, if the recipient doesn't statically link in, is to queue drop. I love that that's the slang term for this. You need to put the constant for that LabVIEW class on a block diagram somewhere. And a great block diagram to put this on is, in fact, the actor core of your remote proxy, of the child of that interface actor. I guarantee you're going to have an actor core. How can I guarantee this? Because you're launching a nested actor. That happens out of an actor core. So just drop your receive message block diagram and do it in the dev, even if you're not thinking of you do an executable, because eventually someone's going to say, Matt, build an executable. And if you haven't done this, you'll forget, and you will wonder why your message traffic doesn't work. All right. So we have solved, provided a solution for the use case of linked actor trees. I've got a remote. It's always running. I want to intermittently connect to it. It calls for two trees. We've got this connection. It's all the way down at the bottom of our hierarchy, typically. And this connection is the network connection. This functions very much like I/O. Okay? We might have an actor that processes some data out of an instrument. Okay? And it's not going to work any differently than this. So conceptually, it's the same thing. And there are times when we would really like to get back to the single actor tree model. Okay? There are circumstances where, having our whole system, I'm just going to launch my top actor, I'm going to fan out to all of my targets, and, do this massive distributed computing thing, and maybe somebody's present, maybe they're not. But I want to be able to do that. We still have this problem, but, can we do this? Now, I'm going to digress for just a second, and I want to give you a use case for where you might want to do this, one I encountered in my own work. It's one of the last things that I worked on at NI. Sadly, it was a prototype for a solution that there are now system engineering has better solutions. That's the way it goes. You write some code, but it doesn't go anywhere. However, it was a useful exercise. I certainly learned a lot doing it. What we were doing was we're trying to integrate LabVIEW with Jenkins. Okay, there was no native LabVIEW API to do that. System engineering actually has some tools to do that now. This is why this is deprecated and nobody cares anymore. But one of our first attempts was, hey, Jenkins talks to a web service, let's make a LabVIEW web service. And then Jenkins can talk to a LabVIEW web service and do all of the Jenkins-y things that it needs to do in LabVIEW. So we built this as an actor framework project because we wanted the concurrency, because Jenkins is highly concurrent and runs a lot of stuff in parallel. And we were thinking it would be really nice to be able to launch multiple instances of LabVIEW and do different things in parallel in different instances of LabVIEW, maybe different versions of LabVIEW. So we wanted those parallel processes. Okay? But we had an interesting challenge. Jenkins wants the web service there always. And ideally, we would like that argues for an executable. But you can't build an executable from within a LabVIEW executable. You can't invoke the app builder. You're not allowed to do so. So that means we couldn't do builds on Jenkins if we did that. So that doesn't work. Also, you really, 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 really want a clean launch of LabVIEW when you're doing a continuous integration step. Okay? Because you don't want to risk cross-linking with something else that you previously loaded. So we had this duality of LabVIEW had to be there, but it also had to go away. Had to always be there and go away. So two instances of LabVIEW. The web service running an executable, and then a LabVIEW instance that we launched and reached into remotely. And we're building an actor system. So the workflow is going to look something like this. The web service has an actor, runs for an actor called the CI mediator. CI mediator gets a job from Jenkins, and it's going to go launch a local proxy to do that job. The local proxy is going to go launch my second LabVIEW instance, reach into that second LabVIEW instance, launch the actual job, and do the work. And when it's done, we're going to roll that all back up. Okay? That's what we want. How do we get there? What's happening here? What is PSM? Interestingly enough, yes, sometimes. Sometimes yes, sometimes no. Yeah. So PSM in this case, it's my wife's phrase for pure freaking magic. What is the pure freaking magic here? And I have two answers for you, which is why sometimes it's a base server and sometimes it's not. First is caller endpoint actors, and we'll spend some time talking about that, and then we'll talk about the other one. Caller endpoints. Remember this diagram? Remember I said there was another child of network endpoints that I would talk about later? It's later. We're going to talk about caller endpoints now. Recall that nested endpoints solve this problem. Okay? Caller endpoints solve this problem. I'm going to have I have a small target application sitting on my remote system, and it has this caller endpoint sitting there that's just waiting for a connection. The host is going to launch its process, which will launch a nested endpoint. You've seen those. The nested endpoint is going to reach out and connect to caller endpoint. Recall that the connections are managed by the parent class, the network endpoint. And then the caller endpoint turns around and launches a bunch of subprocesses. And in that sense, we kind of take the target application out of the picture, and we have something that isn't quite, but looks very much like the actor tree that we want. If the nested endpoint disconnects, the caller endpoint will shut down and kill its process. Kills processes and shut down. If this subprocess dies, and all those actors die because we're using the default error handling, caller endpoint will get a last stack and it'll shut off. It will forward a last stack to nested endpoint. It'll also send that last stack to its caller. So in that sense, it is very tree-like. Not significantly more difficult to use. There's really only one extra step. I imagine there might be a case where your caller endpoint was an initiator, but it seems more natural for you. You do have to tell it what nested actor is going to launch. This is hard-coded at edit time. Okay? Do still have to do things to minimize coupling. The answer continues to be interface actors. Okay? But they come into play a little different. Host side doesn't change. The interface is actually the interface to your remote UI. Okay. So the remote UI interface is the interface. This is the actor that's launched by the caller endpoint. Otherwise, everything I told you spent 10 minutes just now telling you about applies. Now, I wrote this. It was cool. I actually had one iteration of the CI server that used this, and then I wound up not using it. Not because I don't think it's cool, because I had a better solution for this instance, which I will talk about next. That is something called Launch Remote Actor, the Launch Remote Actor package. Stephen Loftus-Mercer put the first version of this out in January of 2013. We couldn't use it on the CI server project because it required an experimental fork of Actor Framework. And I can't tell you, hey, the LabVIEW that's doing your build for you is using an experimental version of a framework that's just for the product. That's a non-starter. But around the time I was working on the CI service, we solved that problem. Receive message was the big thing that needed to be shipping an Actor Framework, and that shipped in, I want to say 14. And once we had that, a couple of other minor tweaks to Actor Framework, and we were able to get a version of Launch Remote Actor that just uses standard AF. And that's the version that's available to you and that I use in the CI project. Exact same job sequence. What changes is what's happening right here. And it is VI server calls, as Nathaniel mentioned. There's actually an upper proxy actor and a lower proxy actor, and they actually communicate through VI server calls and some nifty bait and switch shell game stuff involving rerouting and queuer traffic. I am happy to talk to you about what that actually looks like under the hood. It detracts from the point of this talk today. So I can do it offline, or I think I have the extended version of the slide deck up on my personal website with a couple of slides on what's actually happening here. Suffice to say for now that it works. It's cool. It takes a little while to parse through what's going on and really understand it, which is why I'm not going to go into it right now. The great thing for you, if you want to use this, is it's one VI. It looks like any other launch actor call. It's the exact same API as launch nested actor, except it takes an app retinum as an input. It's the only difference. It drops into your application in exactly the same way. Okay? And so that just means reach out to that machine name on the port number that you're interested in, open a reference to that LabVIEW, and you're good to go. Execution looks very actor-like, as you would expect. It is actor-like. The only difference is you do have to have a few things, again, already loaded into memory waiting for you. Not doing anything. They're just sitting in memory. Okay? Host launcher is going to launch its process. We'll do launch remote actor, launch remote process, which launches whatever subprocesses it has. And the great thing is that we can actually pick the actor we're going to launch at runtime, which is cool. The things that have to be loaded into memory, the message classes have to be loaded, just like with caller nested endpoints. Also, the actor you want to launch has to be loaded into memory. You have more than one. You have several of these. But they all have to be available in memory in your target app. You also have these two VIs, which I've shown here as static VI references. There's proxy actor, redo NQ, and then there's a lower proxy actor, proxy actor. These are just two VIs that do all the VI server stuff, and they have to be in memory. And the compiler is smarter than we are at this point, so you have to go to great lengths to trick it, which is you actually put a front panel indicator on, front panel control on there, and a case structure to keep the stuff in memory. But you do that, and you're good to go. It's just a couple things. So you'll have this little, you have an open VI, or you'll have a little tiny executable running on your target, holding the stuff in memory for you. Coupling gets trickier. That's one of the downchecks to this. You're still going to have like your abstract interface for this side of the house, but because this side of the house is deciding which actor gets launched over here, that static link has to exist. So this level at least is going to be coupled to. Okay. If you've got anything down here that you need to be uncoupled from, this guy is going to do something clever like make a VI server call to launch these specific things you care about to break that connection. So you'll probably again have an interface here. The examples that I've worked, I haven't had to work through the coupling, but it's going to work a lot like this. So it's harder. A little trickier to get that decoupling right. Which means that it's not the solution for every instance. So it's GUs. That's a great question, and you guys are ultimately responsible for making that choice. But I can give you some guidance. Launch remote actor has a brain-dead simple API as far as the user of it is concerned. Just launch the actor like every other of launching an actor. But if that code decoupling is going to be a challenge for you, that might put you back into caller endpoints. Launch remote actor uses the VI server, which is not, you can't secure VI server. VI server may not want to go through a firewall without making your IT people very, very, very cranky with you. Okay? So you may be blocked from using VI server. Caller endpoints use these very security-friendly TCP/IP. There is actually an API for encrypting the message traffic itself. I'm not going to guarantee that nested endpoints are secure, but you can actually encrypt the data traffic. It's possible. It's allowed. Built into that framework. I think, though, this last item is going to be the biggest differentiator, and that is, do you need to specify the target, the actor running on the target runtime? If that's what you need to do, you'll live with these other two things. Okay? If it's acceptable, or you want to specify the lower target at edit time, then you use caller endpoints. So I think this is going to be your actual decision If it's not, it's one of the other things. That's okay too. That's your guidance. Now, that's if you want to do the signal tree model. When do you want to use the signal tree model? Question. The differences between the two are, linked trees are going to be nested endpoints. You have two choices for inter-target trees, caller endpoint or launcher mode. Do you want a client-server architecture? Do you want the remote to always be there that you connect to it? Client connects to it. Or do you want a distributed actor hierarchy like you're more used to? And do you want the caller to determine the life cycle of the remote nested? That's your, so really you've got those two questions. Do I want to connect remotely, or do I want to set this stuff up at runtime? Then, do I want to specify all this ahead of time? I'll be able to specify it at runtime. These are going to be your decision matrices. Hopefully I have you all excited and itching to find this stuff. And it's easy to find because I'm on the tools network. Well, I'm on the, sort of not officially, but that's where you find the stuff. All of these actors I've talked about today, actually the several actors that I've done, are available on the tools network for download right now. You can open your laptops and get them. If you search for not installed actors, you'll get the list of everything with the name actor in the title. Everything I've done with actors has the name actor in it, so that will help you. That's where you get the latest and greatest versions of code. You can go find the original forums pages on them, which often have a little bit more documentation. They have, probably like the original versions. We're not updating the versions on the forums, but you can also find a bunch of commentary from people, which may be useful. So that's where you find the stuff. And that's what I got for you guys. And look, it's 8 o'clock. Questions? Yeah.
I take it you've tested launch remote actor on many different remote targets.
We'll go with that.
Were there any that are, I guess, not ready for prime time yet? Right.
I don't think so. It's just LabVIEW. It's just G code.
If you could talk to a VI server.
Yeah, if you can talk to VI server, it should work. This is all just G code. So that's the great thing about AF is there's no special sauce. You can get a little crazy on an RT target using actors, but it should all work just fine. Anything else? All right. Cool. I have a card if anybody wants it. If you want to use any of this stuff, drop me a line. Happy to help out. And that's what I got. Watch me stop sharing. I'm no longer sharing. Do I know you?
We met at NI Week.